Hello, everyone, and welcome to this explainer. Today, we are going to explore the very essence of the chemicals that make up our world. When you hear the word chemistry, you might immediately picture a bunch of scientists in white coats mixing bubbling liquids in a pristine laboratory. But the truth is, the fundamental building blocks of chemistry are all around us and literally inside us. In this session, we're going to focus on explaining Unit 14 clearly, breaking down the absolutely fascinating world of acids, bases, and salts. We'll use some incredible, practical, real-world examples to prove that you really don't need a lab coat to be a chemist. You just need to look around your own house. Okay, let's dive into this. Have you ever actually stopped to wonder how the food you eat gets broken down to give you energy? It's so easy to think of digestion as just a mechanical process, like a blender, but it's actually a highly active, intense chemical zone. Our body's metabolism is largely driven by a powerful substance called hydrochloric acid. And here's a crazy fact for you. This acid is so strong it can literally dissolve metal. Yet our stomach lining is specially designed to handle it perfectly. It's a natural built-in example of how absolutely essential these chemical compounds are to our survival. Without this highly acidic environment, breaking down your lunch would be nearly impossible. And this chemical presence extends way beyond our digestion. Think about the stuff you use every single day. When you drink a cold glass of orange or lemon juice, that incredibly tangy flavor hitting your taste buds, that's citric acid. When you're scrubbing down your kitchen counters or washing your clothes, the cleaners and detergents doing all that heavy lifting are typically bases. Even the medicines we take when we're feeling under the weather rely entirely on the precise chemical properties of these substances. So they aren't just abstract ideas you read about for Unit 14. They are the active ingredients of our daily lives. Section 1. The science. Acids versus bases. Now, what's really interesting about this is what happens down at the molecular level. When an acid dissolves in water, it releases hydrogen ions, which we call H+. This is exactly what gives acids their highly reactive, often sour characteristics. On the exact opposite side of the spectrum, a base releases hydroxide ions, written as OH-. We measure this huge difference using the pH scale. Acids sit on the lower end of the scale with a pH of less than 7. Bases, on the other hand, sit on the higher end with a pH greater than 7. And right smack in the middle, at exactly 7, is our totally neutral zone, which is pure water. They are literal molecular opposites, perfectly balanced on either side of that neutral mark. Section 2. The meeting of opposites, neutralization. So, what do you think happens when you take these two total opposites and mix them together? It sounds like a recipe for a chaotic explosion, right? Well, the result is actually a process called neutralization. When an acid and a base interact, those positive hydrogen ions from the acid and the negative hydroxide ions from the base manage to find each other. They lock together and essentially cancel each other out. And what do H+ and OH- make when they combine? H2O, pure water. But the remaining elements from that acid and base don't just vanish into thin air. They bond together to create something completely new, a completely neutral product. And that product is salt. So, the crucial point is that when we use the word salt in chemistry, we aren't just talking about those little white grains you sprinkle on your French fries. Salts are a whole category of ionic compounds formed by this very neutralization process. Ordinary table salt, sodium chloride, is just one single example of the many ionic compounds created by mixing acids and bases. And because they're ionic, if you drop these salts back into water, they will dissolve right back into positive and negative ions. It's like a chemical puzzle coming apart and snapping back together. Section 3. Identifying salts in the real world. And this brilliantly illustrates how we actually find these hidden salts using a practical, hands-on experiment called the dry heating test. You start by placing a small amount of your mystery solution into a completely dry test tube. Then you apply some heat. Basic physical tests like trying to smell a substance or just guessing by its color aren't always reliable. And honestly, in chemistry, smelling random things is a terrible, dangerous idea. But by heating the tube, the water inside evaporates. Any salt that was dissolved in the water obviously cannot evaporate, so it gets left behind as a solid residue right at the bottom of the tube. It's a beautifully simple visual proof of the hidden compounds inside a liquid. As we wrap up this explainer on Unit 14, I really want to leave you with a final thought. Take a second and look around the room you're in right now. From the soil in your potted plants, to the household cleaners tucked under your sink, to the very digestion happening inside your stomach, chemistry is literally always in motion. The acids, bases, and salts we've unpacked today are not just stuffy concepts confined to a textbook, they are the silent, invisible forces interacting nonstop to keep our world functioning. So the next time you taste a sour lemon or wash your hands with soap, ask yourself, what invisible chemical reactions are happening right there in front of you? Keep observing, keep questioning, and thank you so much for joining me to explore the amazing chemistry of everyday life.